Hi class, welcome back. We're going to be going through our lesson today that's called factoring and solving. By factoring, I should say solving by factoring. By the end of this lesson, again, just notice that because there's no box here, that means that you don't have homework for this lesson per se. The homework will be in lesson 2, which is your lesson that is about doing some expanding and simplifying of algebraic expressions. You will also have, I will post a solving by factoring handout, so if you could, that can be your homework that you do after you finish with this lesson. I'm just going to write that up here actually for you so that you remember to do it. So just handout solve by factoring. That's going to be good practice for you if you're solving by factoring, you're still a little bit confused about it, and there's some good examples in it. And then we are going to go through that. So again, we're going to start off with our learning goals by the end of this lesson. The things that you should be able to do is factor both 2-term and 3-term polynomials. You'll be able to factor trinomials and perfect square trinomials and find the zeros of an equation by factoring. Take your time walking through this. If at any point you are confused, maybe take a note of it and have it so that you can ask questions. When you're using these kind of videos, the best thing that I can suggest is that walk through them, use them kind of as a way for you to understand the concepts. And then if you have questions, always go back, rewatch, and then ask again if you have questions. Okay, so this is review from last year. So this might jog your memory a little bit, just a little bit of a refresher. So recall that you can always approach a factoring question by examining the number of terms in the expression. The first thing you should always do, and if you remember this from last year, it says find the common factor, right? So let's go in here and do the common factor first. So if I go and look at this, I have 12x squared minus 3x, and I can take out the 3x here, right? Because both terms are divisible by 3x. Just remember that common factoring is just the opposite of distributive property. So instead of distributing the 3x in, I'm actually going to pull it out. Okay, so we have 3x. So what I'm essentially doing inside that bracket is I'm going to divide everything inside that bracket by 3x. And you obviously don't have to show this step. If you can tell yourself, hey, like, I just need to divide by 3x, and you can pull it out in your brain, that is perfectly okay. I'm just showing you for the sake of clarity. So I pull the 3x out. 12 divided by 3 is going to give me 4, not 6. Oh my. 4. X squared divided by x is going to give me x. Minus 3 divided by 3 is 1. X divided by x is 1, so just 1. And then 3x on the outside. If you're ever in doubt of if you factored properly, you can just check your work by expanding and making sure that you get the same number. Okay? So that's how you do that. So when we're doing difference of squares, this is just a kind of quick way to do a 2-term, right? If you look at a difference of squares and you see that there's 2 terms that have perfect square numbers, and most importantly, there's a subtraction sign in between both of them, this means that now you can do this as a quick method, right? And the quick method is basically you can take the square root. So if you have a squared plus b squared is equal to, you can take the square root of the first one, right? And it's the entire term, square root of the second one, add them together. And then in the second bracket, you can take the square root of the first one, subtract it, square root of the second one, right? And that's what you're left with. So a squared plus, oh, sorry, that shouldn't be plus, it should be minus, and it always needs to be a minus. You can never have a plus there. It's not the right answer. And do it that way. So let's do the first one. We have 9x squared here minus 25. It's a minus, so I know I can use my difference of sums rule, right? So let's go here and do that. So I'm going to do square root of 9x squared minus square root of 25. And it's not an equal sign, just make sure you don't add that. It's an expression. Let's do the square root of 9x squared. That's going to be square root of 9 is 3. Square root of x squared is just x. And then my plus the square root of 25, which is 5. And then I'm just going to write the same numbers as the minus. And that's going to be my answer. So I'm going to have you pause the video here if you haven't done this already and go through the second one on your own. It's a little bit more complicated. There's an extra step. So try doing that one on your own, and then we'll come back and solve it together. So okay, hopefully you pause the video. Let's come back and solve that together. So we're going to do, it's a minus, so we can do square root of the first one. Oops, I'm just going to make it a little bit nicer. So square root 81x4 minus square root 16y4, right? So square root of 81 is 9, square root of x4 is just x squared, right? Minus 16, square root is 4, y squared, right? And then we're just going to also have to do the plus on the flip side. Just add the plus, 4y squared. Doesn't really matter which way you add the plus or the minus, they're both the same thing. Now, notice how this term is still a difference of squares, right? This one, on the other hand, is not. So you cannot, it's the plus in the middle that messes this one up, so you can't continue to do that as a difference of squares. So I'm just going to write that down again as the 9x squared plus 4y. You can't make that more simplified, but the 9x squared minus 4y squared, you can. You can take the square root of both of them. So let's do the square root of 9x squared is going to be 3x. It's going to lead you to, and then 4y squared is going to be 2y, right? And then it's going to be 3x plus 2y. And now you can't factor that further. 3x and 2y are not perfect squares. But it's really important to recognize that the 9x squared and 4y you cannot factor further, so you have to leave it as that because it is a it is a plus in the middle, so this plus means that you cannot factor further. I'm just going to make that a note. Okay. So we're going to move on. I'm going to go on to this one. Now we're going on to more three-term questions, right? The first thing is always to find the common factor. So here I like to go in and I actually like to do it number by number or variable by variable. So I always start off with like the numbers first and I see, okay, 6, 2, and 10. What's a common variable between, or a common number, a common factor? 2. So I say, I'm going to pull out the 2. Then I go and look, okay, the next kind of letter is x. The 10y doesn't have an x, so that's not a common factor. And then the last one I check is that there's this y, there's a y here, there's a y here, so I can pull out the y as well. So now I know I can go and divide this entire term, so 6xy squared minus 2xy plus 10. I'm just going to pull out the 2y. So I'm going to go and divide each term by 2y. Each term, that means that everything's separated. Sorry, that's a 10y. Everything that's separated by a plus or minus sign, you've got to go and divide it. All right. So now I'm going to do it term by term, so or just do it by variable. So 6 divided by 2 is going to leave us with 3. There's no x, so we can just leave the x. Y squared divided by y is going to be y minus 2 divided by 2 is going to give me 1, 1, and the y's cross out there. So I'm left with the x. The y's cross out here, so I'm left with 10 divided by 2, which is going to be 5. And 2y on the outside. And theoretically, if I expand this out, right, I should get that answer above. And that's my answer. Now we're going to move on to simple trinomials. Simple trinomials, for a simple trinomial, you're going to try to find two numbers. I like to call these numbers m and n. I've had multiple people tell me that they didn't learn it this way. That's fine. I just like to use m and n because they're two numbers that I remember then, right? And then you can take this into, and it becomes x plus m, x plus n, right? And that's just the way to factor the simple trinomial. So when you're looking for m and n, you want two numbers that when they multiply, they give you the c value. So our c value here is going to be -12. And when you add them together, they give you the b value. And our b value here is going to be -1, just the middle number. Right? If you're wondering where I get the a, b, or the c and the b from, I'm getting it from this equation. Okay, so m and n, when we add them together, are going to give us -1 and -12. So I like to go here and make a little product sum table for myself. So I say, okay, product, and then I do the sum after. It's easier to find the product first than the sum. Okay, so let's find the product. I know that two numbers that multiply together to give me -12 are -1 and 12. If I add those together, I get -11. 12 and -1 also works. If I add those together, I get just 11. -6 times 2 works. If I add those together, I get -4, right? And then I think the other one that I tried was -4 and 3. If I add those together, I get -1, right? This one is the one that fits the criteria. When I multiply these two numbers together, they give me -12. When I add them together, they give me -1. Right? So my two numbers that I'm going to decompose into are -4 and +3. So then what I like to do is I like to actually go right and decompose that middle term. So the middle term becomes 3x minus 4x over here. And then I just like to go in ahead and write the rest of the equation down. Right? Then we can group them. So then I can pull out stuff from here. So from this one, I like to pull out the x. I'm left with, in the middle, x plus 3. I'm going to pull out the -4 from this one, so -4. And I'm left with, in the middle, I'm left with x plus 3 again. These two numbers are the same, so I'm going to say x plus 3, and then the outside one is going to be just x minus 4. Again, if you notice, the numbers are just these two numbers, so you could have just gone and done straight to x plus n plus x minus n, or x plus n, x plus n. It's up to you how you want to do it. You can do it by composition. Simple trinomials, you can just go ahead and put in the numbers if you know what the two numbers are. If you're doing more complex trinomials, you will have to do decomposition or the x method. But if you would like, you can do it this way as well for simple trinomials. Okay, just saves you a little bit of time. So try doing b by yourself, and then we can come back together and take it up. Okay, and so hopefully you took a break. Pause the video if you didn't. I really recommend going and working through these by yourself first. They definitely help you build the skills. So first things first, let's look at the greatest common factor. Our greatest common factor is 2, obviously, not x, because this last one doesn't have an x. So important to remember that. So 2, I just took the 2 out of there, it becomes x minus 6, right? Then I'm going to go find two numbers that when they add together, they give me -1, and when they multiply together, they're going to give me -6. So I went and did that, and I found that they were x plus 2, x minus 3. So I just went and factored straight away. That's just how I do it, because I can. You obviously, if you would like to use decomposition, be my guest, but this is another way to do this. Okay, moving on, let's go on to complex trinomials. Complex trinomials, you need to do a little bit of an added step to that decomposition method. So with simple trinomials, you are really doing what you're doing with complex trinomials. The only difference is that with simple trinomials, the a value is 1. So it's just 1 times c, which is c. In this situation, what you need to do is you need to find two numbers that multiply to give you the 6 in this situation, and the 12, or the -12, and then add to give you that middle term number. So let's go ahead and find out what our a value is here. Our a value is 6, our c value is 12, and our b value is 1. So let's find out two numbers, when you add them together, that will give you -1, and two numbers, when you multiply them together, will give you a times c, which is going to be -3. Okay? So then what we can do is we can now go and find two numbers, or sorry, not -3, oops. It's going to be 6 times -12, so it should give you -72, which is a big number, but If you go through these factors, logically it'll come up. So the two numbers that I know off the top of my head are going to be m is going to be 8, right? And n is going to be -9. So what I'm going to put back in when I decompose that is going to be negative 9x and then positive 8x. So I'm just going to go ahead and do that. So I'm going to write out my new terms with the decomposed middle term. So I'm going to do 6x squared my plus 8x minus 9x minus 12. And if you wrote 8x after the minus 9x, it's all going to be the same. Just make sure you have the right negative and positives where they need to be, but you'll get the same answer. Let's pull out from this one. We can pull out a 2x, right? And I'm left with 3x plus 4, right? Out of this one, I can pull out a 3, right? And I'm left with 3x. I can pull out a -3 rather, and I'm left with -3, positive 3x plus 12, right? And then just group everything together, 2x minus 3, 3x, oh my goodness, not plus 12, it's plus 4. Sorry about that. 12 divided by 3 is 4, plus 4. And that is my answer. I'm not going to write the equal sign there, it's not supposed to be there. That is the most simplified polynomial in that situation. Perfect square trinomials are the next one. Perfect square trinomial is just a special type of trinomial. So if you see that something has 3 terms and the first term is a perfect square and the last term is a perfect square, check to see that the middle term works. So if the middle term is 2a plus 2ab or minus 2ab, you can write this as a plus b squared or a minus b squared. This middle value will always come from whatever the value of the middle term is. So if it's a negative, it'll be a negative. If it's a positive, it'll be a positive. So let's do one example together. We'll do 9x squared minus 30x plus 25, right? Easy peasy. So I noticed that this is a perfect square and this is a perfect square, so I want to check if this is a perfect square trinomial. So what I like to do is I actually like to just, I like to split it up into these two components, right? And I like to say, okay, let's go here and go, what is the first one square root? So we're going to do 9x squared. That's going to give me 3x, right? What's the square root of 25? Just what's b? Right, and that's going to be 5. Battery's running out here. Then I take the two terms and I say, okay, what's 2 times 3x times 5? Right, 2 times 3x is going to give me 15x times, 2 times 3 is going to be 6x times 5 is going to give me 30x, right? This middle term now matches this middle term here. Right, so I know that this is a perfect square trinomial. So what it will look like is going to be a minus b squared. And the reason it's minus b is because this minus is coming from here. Right, so the a value I know is 3x. The b value I know is 5. I know there's a minus in the middle, and that's going to be my answer. Perfect square trinomials, even if you did it by decomposition, will give you the same thing. So if you feel like this is wasting your time, don't do it this way. Do it the way that makes the most sense to you. Okay, last but not least, we're going to move on to solve by factoring. This is the stuff that tomorrow, so at the time I'm posting this on Wednesday, I do want you to go over in class. So you're going to watch this in class together, or you're watching this in class right now as I'm speaking. And I also want you to do the solve by factoring handout. So I'm going to post a handout. Do that after you have finished your in-class lesson, which says lesson 2, simplifying and expanding polynomials. It's just a review of this stuff. It's still grade 10. Do this after that, or do that homework handout after that, because it'll just solidify this thinking. It's a really good handout. It's kind of has a lot of word problem, has more complicated questions on it as well. So go over that as well. So one thing I want us to note when we're solving by factoring and not simplifying by factoring, solving by factoring you can only do when you have something that has an equal sign in it, right? So notice that all the previous questions were expressions. You were asked to factor them. The next questions are equations in which you use factoring to solve for the unknown variable. So what you can do is you have to rearrange the equation, make one side equal to 0, and this will help, and it'll help you if the x squared term is positive, then use the zero product property to solve for the unknown variable. So I'm going to do that with you right now, and I know you're looking at me like, oh my goodness, or you're looking at your supply right now and you're saying, oh my goodness, what is the zero sum property? I will go over what it is. Once you see it, it will jog your memory and you will remember what it is. So if I'm given something like this, I want everything on this side to equal to 0. So I want to get rid of that -1 over there, right? So let's move it over. To get rid of the -1, we're going to add a +1 to both sides. So I'm left with x squared minus 10x plus 20 plus 1 equals -1 plus 1. This is going to give me 0, right? So I'm left with x squared minus 10x. 20 plus 1 is just 21. Right, now this is a simple trinomial. We need to find something that when we add it together will give us -10, and when we multiply it together will give us +21. Right, so our m and n term in this situation, if you would like, take a moment, pause, think about it, but I'm going to write it down and say it's -7 and -3. Right, so then what I can do is, because it's a simple trinomial, I can just go ahead and say, okay, you have -7. X minus 3. If you did this by decomposition, it would be the same thing. Just skipping ahead because in the interest of time I'm doing that. 0, right? Now, this is where that zero product property sum comes in. Zero product property. The zero product property just states that when one bracket is equal to 0, the entire equation is equal to 0. Right? So if I want to find out what x is, I just need to make one of the brackets equal to 0. Right? Because if that bracket turns to 0, then the other bracket is multiplied by 0, and automatically the entire equation is equal to 0. So what you do here is you just go in and you say, okay, so I have x minus 7, x minus 3 is equal to 0. So you make each of the brackets equal to 0. X minus 7 is equal to 0. So I'm just going to go in here and kind of draw it out. And then x minus 3 is equal to 0. Right? And I'm just going to make, I'm going to solve for x. So if you solve for x, get rid of the -7 here, add 7 to both sides. I'm left with x is equal to 7. And I'm left with x is equal to 3. So my two solutions for this are x is equal to 7 or x is equal to 3. And both of them will give me what I want. So try going through B by yourself. It is a little bit more complicated because the questions are a little bit more trippier. The numbers are a little bit trippier, but try doing it by yourself. See if you can find it. If you get a fraction, it is right. Don't worry about it. Don't let that stress you out. But let's go and try that one by yourself. So pause this video, try it by yourself, and then we'll take it up together. If you would like, this is a great time to talk to your elbow partner, talk to your neighbor, and ask them what they think after you've tried it by yourself, and then we can take it up together. Okay, so hopefully you paused that video. If you didn't, pause it now, okay? And we're going to take it up. So we have 2x squared plus 5h minus 3. Can't really take anything out from here, so you're stuck with what you have. So we're going to do m plus n. This is a complex trinomial, so you do need to do decomposition. Your middle term is 5, right? M times n is going to be 2 times the negative 3, which is going to be negative 6, right? Because it's complex, you need to make sure you take that 2 into account, right? So what are two numbers that when you add them together will give you 5, but when you multiply them together will give you 3. So think about that. Negative 1 and 5, or negative 1 and 6, right? If you have negative 1 plus 6, you're going to get 5. Negative 1 times 6 is going to give you negative 6. So let's decompose our little equation here into 2h squared minus 6h plus, sorry, not minus 6h, it's plus 6h. Plus 6h minus h, right? Because 6 minus 1 is going to give me, and you can write 1h, there's no problem with that. I just don't write it because of form. Minus 3, right? Let's go in and group them together. So I'm just going to pull out here the 2h squared plus 6h. I can actually pull out 2h. So I'm left with h plus 3. And here I can pull out the negative 1. So negative 1. You can leave the negative 1 as it is, or you can just get rid of it. Doesn't matter. And then you're left with h plus 3. Right? So now I'm left with 2h minus 1, because that negative 1 is there. That's why I like to write it there, plus 3. Right? You factored it. It's all equal to 0. Make sure you always make them equal to 0. That's good form. Now we're going to make each bracket individually equal to 0. 2h minus 1 is equal to 0. H plus 3 is equal to 0. Right? So like, let's isolate for the 2. It becomes positive 1. Divide both sides by 2 because you want to get rid of that 2. And h is equal to positive 1/2. Same thing on the other side. H is equal to 3. You just add minus 3 because you're subtracting 3 from both sides. And those are your two solutions. Okay? So note that when you're checking solutions, you need to plug in both the negative 1 over 2 and the, you need to plug in both the 1 over 2 and the negative 3. And both of them will give you 0, but you do need to do that when I ask you to check a solution. We do left side, right side check. And that's all for this particular lesson. Thank you. Have a great day.